Hello everyone. For today we're going to go over an independent sample t-test. So as a reminder, for an independent sample t-test, our groups are mutually exclusive. That's the big part. We'll get into, and if you have questions, the dependent sample t-test. Typically that's time 1, time 2, before and after, pre-post. But today we're going to focus on independent samples t-test. So with that, I have the formula here to calculate our t-obtained value. Everything in it you should be familiar with this at this point. If you need a reminder for the variance of the s squared on both for sample 1 and sample 2, go back to the variance video itself. I'm not going to go in on this video and calculate it by hand. If you have questions, please refer back to that video. But here for this example, made up a couple different samples. We have people who drank coffee and people who did not, so natural, and looked at the number of words typed correctly per minute. So a treatment effect kind of between two different groups, one that had coffee, one that did not. I summarized, and if you're wondering like where I came up with this data, I pulled it from Excel. I made it in here, truly random data. Even in the sheet before, I used a random number generator. So if I were to click on one cell, you can see the random between, and as I click on it, it typically changes values. Copied it over, ran it in Excel, and just use the summary values here. But I'm going to go through and show you how to do it by hand. So with that, we have the values that we need, but the key part with any of these is to start off with our null hypothesis. So again, H0 is the mean number of words typed per minute does not differ across the two groups. So we see equality here. Our research hypothesis, on the other hand, expects a difference. So our research hypothesis would be an example of one. The mean number of words typed correctly per minute differs across the two groups. So the mean, we're not saying a direction, so the mean of sample 1 does not equal the mean of sample 2. So we expect a difference between those who had coffee before the typing versus those who are just natural with no caffeine in their system at that point from coffee. So with that, we understand now that since there was not directionality in the statement, we didn't expect one to be greater than or less than. It's going to be non-directional. And this is important because we need to look up the two-tail value for it. And here, let's set our confidence or risk level to be 0.01. So again, I've already pulled up a table that I've provided in my class. So if you're interested, remember, this is our obtained or critical value that we need to get greater than to say that there is a significant difference or there's not. We reject or fail to reject the null hypothesis. So our value for 0.01, and remember the key part here is that it's two-tail. So two-tail 0.01. And you might look at this table and see, well, it's different than a z-score table and that. The key part here is on the left-hand side with the degrees of freedom. This refers back to our two sample sizes minus 2. So if we come back here, it's actually the denominator of the overall formula. But since we know we have 29 in each, so it would be 29 plus 29 minus 2. So here we would have 58 minus 2. So our degrees of freedom equals 56. So when we go back to the table, we know it's two-tail, 0.01, and 56 are degrees of freedom. So again, two tails, 0.01, and let's go down. The closest we can get is 40 or 60. For this one, if we go under, it's going to give us a higher value. So let's use at 0.01, two tail, let's use 2.70. So our T critical equals 2.70. So that's what we're going to compare our obtained value to, is this. So now we have our formula up here. Let's just go through right now and fill out the basic formula part of it. So here we're going to have T Sample 1, let's use 86.21 for coffee drinkers, 96.14 for our natural sample. Square root, the sample size of our first group, 29 minus 1. The variance of that one is 228.24 plus the sample size group 2, which is still 29, multiplied by the variance here is 218.05 over our degrees of freedom, since we already calculated this. So here again, you see sample size of the group 1 plus sample size of group 2 minus 2. I'm gonna go ahead and put 56 down here since we already calculated that. And then don't forget on the right side, so let me draw that out a bit more, put brackets around here. We have 29 plus 29 and 29 times 29. All right, so I'm gonna go ahead and use a calculator on the side, not on the screen. So in the numerator, we're going to have 86.21 minus 96.14 gives us 9.93. Now let's work on some of the denominator, and I'll do this in multiple steps. So here then we would have 28 times 228.24 plus 28 times 218.05, still over 56. Bracket that, extend the square root. And then here we have 58, the numerator, and then 29 times 29, 841. All right, so let's continue to solve for t to get our obtained value. So we still have 9.93. Here we have 28 times 228.24 is 6390.72 plus 28 times 218.05 gives us 6,105.4, still over our 56. This is still in brackets. And over here on the right side, 58 divided by 841 gives us 0.06. So let's continue to work down here. 9.93. Then let's add the numerator of that together, 6390.72 plus 6105.4. So we have 12,496.12 over 56. We still have the 0.06 over here. So now let's do 9.93, divide the 12,496.12 by 56. So now we get 223.15 with rounding times 0.06. We're getting there. So now let's keep moving down. Still have 9.93 in the top, the numerator. And now in the denominator, we have 223.15 times 0.06 gives us 13.39 with rounding. So 9.93 over square root of 13.39 gives us 3.66. So our t obtained would then be 9.93 divided by 3.66, 2.71. So here our obtained value of 2.71 is slightly larger than our t critical value. So here we can reject the null hypothesis of equality and say that there is a significant difference in the mean number of words typed correctly per minute between coffee drinkers and natural non-coffee drinkers. Again, we can see that it's slightly larger. And keep in mind, you might be wondering, well, this differs from the actual value that you glance at in Excel. If you looked at our t table here, we did have to move our critical value to reflect a different degrees of freedom because there was not exactly 56. So with that, we made it smaller to where our degrees of freedom and then corresponding value is more conservative. So from that, if we come back in here now, and this is 56, and if you looked at here, it was two tail. So our critical value for 56 was 2.67. So even when we have that, if we use the Excel for that, it was 2.67. We're still greater than our critical value. So our obtained, so here we can say there's a significant difference in the mean number of words typed correctly per minute between natural and coffee drinkers. So with that, now you could stop there and be cool, that's great, we see that there's a difference, but a key question that comes up often is, well, what's the actual effect size? And we can actually calculate that. We can get a effect size of small, moderate, or large. And to do that, I'm going to write the formula on the side here. So let's see if the difference between them, and we see that the natural non-coffee drinkers had a higher mean number of words typed correctly than our coffee drinkers. So for effect size, I'll zoom out a little so it's a bit easier to see. So effect size is the mean of sample 1 minus the mean of sample 2 all over the variance here. So with that, we know these values already because we already have calculated them here in front of us. So if we fill out this formula, and I'm going to just switch colors so we can identify that it's effect size and not the t-test. Let's fill out for the effect size. So let's do ES equals 86.21 minus 96.14 over variance of sample 1 of the coffee, 228.24, plus the variance of the natural, 218.5 over 2. So here, again, this should look familiar in the numerator, same as the t-test, so we already know that that's going to be 9.93. So for the denominator, let's go ahead and then add 228.24 plus 218.05 gives us 446.29. We're going to divide that by 2, and it gives us 9.93 over square root of 223.15 with rounding. Let's go ahead and take the square root of that. $223.15 gives us 14.94. So we know our effect size is 9.93 divided by 14.94 gives us 0.66. And typically anything over 0.5 is a large or strong effect size. So with that, we know the difference, the effect size between coffee drinkers and our natural non-coffee drinkers when it comes to number of words typed correctly. Between the two groups, there's a strong effect size with a statistically significant difference in the mean number of words typed correctly per minute between natural non-coffee drinkers and coffee drinkers themselves, with natural sample having a higher mean number of words typed correctly than our coffee drinkers. So if there are questions of that, please let me know, reach out. We covered how to calculate an independent sample t-test, looking up our degrees of freedom here with our critical value, even compared it through the Excel version, and get it and calculate our obtained value, and then did an extra step of calculating our effect size to know the effect size, the magnitude of that difference itself. So is that a complementary statistic? Yes, but it helps us understand the difference a bit more. When there is a statistically significant difference, we understand the magnitude of that difference between the groups. So if there are questions, please let me know. If not, cheers.